check out this. Look at this. This is our first point of discontinuity. Yay! Don't freak out. Just remember what I taught you. Go back and start with everything we have here. We'll get to the point of discontinuity in a second. Don't worry about it. Vertical asymptote. Look. Goes right through 1. Yay. So x value is x equals to 1. Of course, a partial equation is x minus 1. Yippee skippy. Point of discontinuity. Let's take a look at that right now. It is at minus 1, and it looks like it's like about 2.7. So point of discontinuity is minus 1, 2.7. But if you remember correctly, we find this later on in the equation. We don't find it now. We find it later on. So I don't really care about the y value. What I do care about is this. So x equals to minus 1, which means that if you think about it, you must have canceled that term out. That's what gives us the whole. So if you think about it, this must mean that you must have canceled out an x plus 1 over an x plus 1 value right there. It must have canceled out in order to give you that point of discontinuity. Let's go to the x-intercept now. Is there an x-intercept? Of course there is, right there at 3. So you've got x equals to 3. Now, remember then that that's also in our numerator. So we've got this becoming x minus 3 as a partial equation. Y-intercept, yep, it's there as well. The y-intercept's all the way over here at 4. So, of course, the y-intercept at y equaling to 4 just means 0, 4, and that's going to help us find the a value. So, here we go. Y equals to, don't forget the a value. Now, look at your numerators, okay? Remember, your vertical asymptote is in the denominator. Okay, your x-intercept is in your numerator, and point of discontinuity is in both. Got it? Okay, x-intercept first. So with the x-intercept, of course, we have an x minus 3 value here. We have a point of discontinuity, which is x plus 1 over x plus 1. And finally, we have a vertical asymptote, which we know is going to be at the x minus 1 here, because all vertical asymptotes become non-permissible values, and those are in our denominator. Yay. So the only thing we have to solve for now is this a value right here. Okay, so y equals to 4. Don't forget all your zeros. All your zeros. So if this equals to 4, that's 0, that's 0, that's 0, that's 0. Check it out, okay? You have minus 3, so this is 4 equals 2. On top, an a, of course, minus 3, and a 1. On the bottom, you have a 1 and a minus 1. Holy smokes, that is a mess. Well, let's clean it up. 4 equals 2. On the top, there's the minus 3 times the 1, right? The minus 3 times the 1 is minus 3a. On the bottom, you got a 1 times the minus 1, so that's a minus 1. Oh my gotcha. That just works out to be how simple? 4 equals to 3a. Divide by 3, divide by 3, you get an a value of being 4/3. Sweet. Now, all you have to do now is to pop that into your equation. And remember, your equation is y equals to 4/3. Your numerator from up here, which is an x minus 3, an x plus 1, because that's our point of discontinuity that got cut out there, that gets canceled, over your other point of discontinuity. There it is, right? The two of them together become that point. And, of course, your x minus 1. Beautiful. Now, let's see if we can graph this and get that exact same value. Okay, so here we go. So first things first, we're going to have to put, guess what? Yep, you're going to have to put in an alpha numerator over denominator, but don't forget you have a 4/3 up there now too. So guess what? You're going to need another alpha denominator up top there. Oh my goodness. There's your 4/3, okay, right? Bring that out. Your next thing is an x minus 3, and your x plus 1, because that's your point of discontinuity that gets canceled out. On the bottom here, you have an x minus 1, because that's your asymptote, right? And the rest of your point of discontinuity, which was an x plus 1. Boom. Okay? Graph that puppy. Let's see if we get the right thing. Oh my goodness, that looks very, very similar to what we have right there, doesn't it? Wow, even if we clean it up a little bit, that looks really, really, really close, doesn't it? Well, okay, let's figure out if we actually have a point of discontinuity. Go back to your graph here, go second table, and look at it. What you should look for is the -1. And sure enough, there's the -1 that indicates your point of discontinuity. There is your asymptote, and everything looks right with the world. And as a matter of fact, wow, I love the fact that this calculator, because I put it in fractional form, gives me results in fractions as well. That's just an extra little added perk.